Hey math kids, today we're going to talk about growth and decay and just get started. So, a scientist monitoring a grasshopper plague notices that the area affected by the grasshoppers is given by this equation. Okay, and where n is the number of weeks, so n equals weeks of from the initial observation. Okay, so part A, find the original affected area. So the original is actually just this piece. So original equals 1,000 acres. Okay, find the affected area after 5 weeks. So 5 weeks. What we're going to do is we're just going to plug in a 5 for this. So we're going to get 1,000 times 1.15 and then plug in a 5. So we'll just use a calculator for that. So we get 1,000. Whoops. Times 1.15 caret 5. Alright, so we hit enter on that. And we get 2, let's see, we'll want to do 3 significant figures, so it's 2010. So 2010 acres. And then we're going to look at 10 weeks. And so we use the same equation, but instead of plugging in a 5 right here, we plug in a 10. Go back to the calculator. A cool trick on these calculators, you can go second entry, second entry, and then we can just change that 5 to a 10 and hit enter. And that's going to be 4050 if we do 3 significant figures. 4050 acres. Okay, draw the graph of the affected area over time. Okay. So we know if we plug in a 0, or our initial is 1,000. So let's just do 1,000, 2,000, 3,000, 4, and 5. Because for the data that we have, we don't go past that. Okay, so at 0, we have 1,000. And then if we go 2, 4, 6, 8, 10, that's all the data that we have right now. 5 is about 2,000, and then 10 is about a little over 4,000. Alright, that doesn't look perfect, but it should look exponential. If my scale was drawn perfectly, then that would look a little bit better. Now D says use your graph or technology to find how long it will take for the affected area to reach 8,000 acres. So we're going to plug in 8,000 right here. So we're going to say 8,000 equals 1,000 and then 1.15 to the x. Okay, like on the previous video, the easiest way to do this with technology is just graph both sides. And so I'm going to do 8,000, and then I'm going to do 1,000 times 1.15 raised to the x. We graph it. I don't think anything's going to show up because my scale is no good. And what it's done thinking. Okay, so what we're going to do, we're going to go to Window. And if we look at our yellow graph, we see that we have to go at least to 5,000, but I'm actually going to go to 10,000 just to see. So I'm going to go for as far as my Y, I'm going to go from 0 to 10,000. And the weeks, I'm going to go like to 20. So I'm going to go 0 to 20. Now this may not be a good window, but let's just see what happens if we can see it. Okay, why did that not draw? Because we could, let me see, window, oh, 10, 1, 2, 3. Okay, those are 8,000. Okay, there we go. I don't know what happened, why it didn't draw everything, but okay. Or, I mean, the window was only 1,000, that's why. Okay, now when these cross, that's where our answer is going to be. So we go second, calc, go down to intersection, and we click first curve, second curve, and then we guess. So we click where we think they cross, which is about right there. Okay, the intersection is at 14.9. So I'm going to write that down. 14.9, and that'd be weeks. And that's essentially it. So at 14.9 weeks, it would be 8,000 acres affected. All right, let's try another one. So that was a growth problem. So I'm guessing this will be a decay one, but let's see. So it says, when a diesel electric generator is switched off, the current dies away according to the formula I of T equals 24 times 0.25 raised to the T amps, where T is the time in seconds. After the power is cut. Okay, so part A, we want to find I of T for T equals 0, 1, 2, and 3. Okay, so we're just going to plug in a 0, we're going to plug in a 1, we're going to plug in, etc. Okay, so for T equals 0, this is going to go to a 1, and so we're just left with our initial, and so we get 24 amps. Okay, now T equals 1, what's going to happen? Let's see, let's clear this. Just plug this in with a 1, so it's just going to be 24 times 0.25, and so that's going to be 6. Okay, T equals 2. I'm going to go back to the calculator. We're going to say 24 times 0.25, and we're going to square it. So that's 1.5. And then T equals 3. Pretty much the same thing. This time I'll do second answer. No, not second answer, sorry. Second entry. Then change that to a 3 and 0.375 amps. Okay, so we found all the values. We can see that it's falling pretty quick. And now we're going to move on to part B. What current flowed in the generator at the instant it was switched off? Well, if we look at everything we just found, this is the instant that it switched off, and so the answer would be 24 amps. Okay, part C. Plot the graph of I of T for T greater than or equal to 0 using the information above. So we're going to use all this stuff that I did in orange and make a graph. So we're going to have a graph like this. Let's go by fives, I guess. So 25, 20, 15, 10, 5, and then 0 would be down there. And then our time in seconds only goes to 3. So 0, 1, 2, 3, I guess 4 right there. Okay. So at 0, we're 24. So we're about right there. At 1, we're at 6. So we're already substantially lower. Then we're at 1.5. And then we're at very close to 0. And so if we connect these dots, which I'm going to have a really hard time doing, we can see that that's an exponential decay function. Okay, part D. Use your graph or technology to find how long it takes for the current to reach 4 amps. So just for precision, because my graphs are never that great, I like to use technology for these parts. And so we're going to plug in 4 amps right here. So we're going to get 4 equals 24, 0.25 raised to the t, or since it's our calculator, we'll call it x. Okay, so we're going to bring this up, clear this, type in new equations. So this time we have 4, and then we have 24, 0.25 raised to the x. Now when I graph this, it's going to look really bad because we have that window from that last problem. It's going to be really hard to see anything. So we need to go back to the window. And if we look at this thing, our x is going to go probably 0 to 4. And then our y would be like 0 to 25 maybe. Whoops. This one should be 0. Okay, so let's try that window. That looks a little bit better. Cool. Now we see they cross right here. And so we want to go second, calc, intersect, and first curve, second curve. And then we're going to guess. And it's 1.29. So at 1.29 seconds, it will be at 4 amps. Okay. If you need additional help, please come to Math Lab, but until then, calculator.